All right, quick show of hands in the audience. Who here has data that you want to preserve? Feel like that should be everybody? Yeah, that's a pretty easy question. So whatever your business is, you might have data that you're required to keep because of legal obligations, compliance requirements. You might have data that's sitting in boxes that you would love to get better value out of. Or, like my customer here, you might have a library full of rare and valuable manuscripts, books, academic records going back hundreds of years. And that's what we're going to talk about today, but it should apply to any number of industries. So my name is Chris Keene. I'm a solutions architect at AWS, and I support the University of Illinois. Before I joined AWS, I was the cloud architect at the University of Illinois. So I'm really happy to be back with my friends, working on some of the same projects. And I'm really excited to see, in this one particularly, how far the library has come over the past 5 years we've been working on this?
Yes.
And what we've been able to achieve. So Joe, would you like to introduce yourself?
Thank you, Chris. I am Joe Troy. I'm a web applications developer and architect at the University of Illinois, at the University of Illinois Library. And today we are going to talk about the University of Illinois Library's digital preservation efforts. First, a little bit about the University of Illinois Library at the Urbana campus. Per a 2020 study, it was ranked the third largest library in terms of physical collection of all U.S. academic libraries. But we also have 2.6 million items in our digital collection, and that's our focus of today's talk. So what we're going to talk about today, we're going to talk a little bit about the digital preservation at the University Library, and then we're going to talk a little bit about the motivation for moving to Amazon Web Services, both in terms of the desire to no longer manage hardware and to improve our storage. Then we're going to talk a little bit about how we use S3, our journey to using S3, and then finally we're going to talk a little bit about how the University of Illinois Library saves money on their AWS cloud costs. So the image you see here is a camera workstation at the library. It is used to take photographs of old, rare, and sometimes very fragile books. You'll notice the V shape. That's because some of the older books, if you lay them totally flat, you would damage the binding. So that's kind of the design features for this camera. The mission of the preservation staff at the University of Illinois Library is to provide continued use of digital objects to our users that are maintained by the library. So Chris kind of talked a little bit about what kind of digital objects that we have in the library. They could be digitized books, born digital books, photographs, audiovisual materials, scholarly publications, and research data. So now let me introduce the Medusa digital preservation web applications. A little bit about the name Medusa. Medusa is a figure in Greek mythology that could turn people to stone just by looking at them. What we aim to do is to turn data into stone and to keep it for a very long time. So our digital preservation web applications, we start with the Medusa Collection Registry, which is a web application used to manage our digital collection, and it is used by our digital preservation staff. The middle web application we have here is the Illinois Data Bank. The Illinois Data Bank allows researchers at the University of Illinois to upload data sets. It allows the researchers to work with our librarians to curate those data sets, and then it makes those data sets available to the public. And then finally, over on the far corner is the Digital Collections web application, which is basically a public portal where anybody can go in and view the public items in our digital collection. So these web applications run on EC2's instances, and we also use other AWS services such as Amazon S3, Amazon Relational Database Service, OpenSearch Service, Fargate, and AWS Lambda. So back in 2017, we were all on-premise with our digital preservation web applications. And so what we're going to do, we're going to kind of describe what we had on campus, how that worked, and then show you how we've kind of replaced things with services in AWS. So our 3 web applications were running on virtual machines on campus, as well as some of the back-end services, such as our database, such as our search functionality, Solr, our search functionality. We had a IIF image viewer, which ran on a virtual machine that allowed kind of a rich image manipulation by our web application users. We also had AMQP software, which is Advanced Message Queuing Protocol software that allowed software components to send messages to each other. And we also had a VM called the Data Mover, which was necessary for our on-premise implementation because sometimes the data had to be moved so it could be accessed by our web applications depending where that data was in the process. Of course, if we had virtual machines, we also had hypervisor infrastructure and software that we needed to manage those things. As far as storage goes, we had on-premises library storage, on-campus storage, and at that point in time, back in 2017, we were using Amazon S3 Glacier Flexible Retrieval for our data backup. So now, as we move forward into today, we're going to explain what our kind of setup looks like today. So we have replaced our virtual machines for our web applications with Amazon EC2 instances. For our Postgres, we are now using Amazon Relational Database Service instances. And for Solr search functionality, we are using Amazon OpenSearch. For our IIF image viewer, we're now using Amazon Elastic Container Service that runs Docker containers using AWS Fargate. And for the AMQP software, we're using Amazon Simple Queue Service. Because we're using S3 today, we no longer need the Data Mover virtual machine, and because Amazon manages all the EC2 instances, we no longer need hypervisor infrastructure. So those are gone. As far as storage goes, our library storage and our campus storage is now Amazon S3, and we're now using Amazon S3 Glacier Deep Archive for the backup storage because that's the most economical S3 data store.
Yeah, and Joe, the thing that jumps out to me from this is all the things that the library is not doing anymore. Because if I look at the back-end services and the storage, that's all entirely Amazon managed, and it frees up time for the library to focus on things that your patrons care more about.
Correct, right. And we'll talk a little bit more about that later. So I'm going to go through some of the process that happens in our digitization efforts. And first we're going to talk about the imaging of physical items. We already saw a picture of the camera that we use to take images. And then once we take a picture of an image, often on the camera workstation, our staff will do some modifications to that image, such as exposure adjusting and that type of thing. And then from there, we put stuff into a storage area, and today we're able to use either local drives that we use sometimes, but we also use Amazon S3 as the staging area. And this is the staging area before it gets kind of ingested into the Medusa system proper. So we do have what we call the ingestion process is called the Medusa accrual process, and that's done on an Amazon EC2. And when that process runs, it puts the digital objects into Amazon S3, and then it puts the metadata and other data needed to manage the collection into Amazon Relational Database Service instances. We also have other digitization processes. The slide I'm going to show now is kind of a collaboration between one of our business partners. The library owns large amounts of newspaper microfilm reels that has images of old newspapers on them. We actually ship those reels to our business partner. They actually digitize it for us. Then what they do, they upload the digitized materials into their own S3 bucket, and then they send those materials from their S3 bucket to a S3 bucket that we have that has a custom policy that allows our business partner's S3 account to put data into that S3 bucket. And I should say only our partner's S3 account. And then from there, typically the newspaper digitized items go to processing on a workstation where our staff might unzip the files, they might make sure things look correctly, they might make sure that the source and the dates and everything else on those objects are correct. And then finally, we put it into a S3 bucket to be ingested into the Medusa system at a later point in time. So this item is about making digital items public, and I should say that not every digital item in the Medusa collection is public, and that's mostly for copyright reasons. But when we acquire, to get an item to be public, the first step is to acquire the digital item, and then the next step is to assign it to a Medusa collection. And that collection may be Shakespeare manuscripts, it may be maps of Illinois towns and cities from the 1800s. Those are the different types of collections we have. There's also like a collection of a lot of aerial photographs of the University of Illinois. So once we assign it to that item, once we assign it to a collection, we go through the accrual process, and that actually moves the data into Medusa. But we're not quite yet done making it public because there's a cataloging process that's a manual process by a librarian where they make sure that the items have the correct author attribution, the correct source, and the correct title. And then after that's done, we can publish the item in a synchronization process. So we've talked a little bit about the motivation for going to S3 storage, for reducing our reliance on hardware, our need to actually maintain hardware. Now we're going to talk a little bit about the motivation to move to cloud storage. At the library, when we had on-campus storage, the issue was that as the library's needs were growing, the on-campus storage was not so big that it had lots of excess capacity. So there was always kind of a physical process in getting new hardware and a management process of setting it up before the library could expand its storage. What that meant is that sometimes our applications had to be put into read-only mode and thus disrupt kind of the work of our digital preservation staff. So initially we were looking at both Amazon S3 or Amazon EFS, Elastic File Service, to use as cloud storage. And one of the big motivation factors was that with Amazon Storage Solutions, they have the excess capacity, so whenever the library would need more storage, it would already be there. Also, because Amazon storage is pay for what you use, we would never have to buy excess capacity that we would grow into. So we talked a little bit about EFS and S3, and Chris is going to talk a little bit more about that in a moment, but we finally did go to S3, and so the other motivating factors of Amazon S3 is its availability and its durability. So I'm going to talk a little bit about availability, and then Chris is going to cover the durability. So as far as availability goes, our on-campus storage occasionally had periods where the data was not available. The on-campus storage was really designed for research data, and they would have regular weekly outages that could be as long as 8 hours. So those were times where our digital web applications would not be available to our users. We also had sometimes on-campus unexpected unavailability, and they might happen either during off hours or during business hours, and that really kind of caused a problem for us. So far with our experience using S3, we have not had any of those type of outages. So with that, I'm going to turn it over for Chris for a bit, and he's going to talk about durability.
Sure. The other really compelling aspect of S3 is the data durability. And we described that in terms of the likelihood that your data will be stored safely for long periods of time. So S3 is designed for 11 nines of data durability, and I don't need to go into that. That's a lot. That's a pretty good promise. So the way we do that, and the thing that I really enjoyed talking to the library staff about, is that when you upload a file to S3, we actually keep a minimum of 3 distinct copies of that file in 3 different availability zones within the region. It's a minimum of 3. In certain cases, you might have more. And so we constantly monitor all 3 copies to make sure that they remain good. If there's any bit rot, if there's a hardware failure, if there's some sort of natural disaster, our system will immediately take one of your other 2 no good copies and copy it over to a 3rd one, so you're right back up to that minimum of 3. And so that, combined with cross-region replication, allows the library to have 3 copies in one region and another 3 copies hundreds of miles away across the country. So how did your librarians feel about having 3 plus 3, 6 copies instead of 2 that they had before?
Well, 6 is really good, but preservationists, they really care about their data, and they really love their data. So there's even been talk about having a 2nd backup, which would mean a 3rd copy, which really means 9 copies.
All right, we might go to 9 copies then. We'll see what happens. So I also want to talk about kind of the thought process that went through this migration, because at the beginning of the journey, the Medusa application wanted to move as quickly as possible because the library was facing on-premises storage that was running out of support. They wanted to get all the data off there as quickly as possible. So they didn't have a lot of time to change the way their applications worked, put in development cycles, and improve things, make them more cloud native. So the first thing we did was we took the virtual machines that were running on-premise, we moved them to AWS on EC2, and we connected them to the Elastic File System, which is an NFS file system, and it allowed the applications running on it to continue reading data from the local file system just like they always had. So it was a very easy transfer. The applications continued to work perfectly, and the developers didn't have to make any changes. What the library discovered was EFS worked really well for them, but it's more expensive than S3. So they wanted to look at a more cost-effective option. So that's when we brought in the AWS Storage Gateway, which allows you to store your data in S3, but still presents that data via a network file system, much like they were using before. And that started off really promising, but we found that the library for this particular application had some very large batch processing that wasn't a good fit for the caching on the storage gateway. And they didn't get the performance that they wanted. So while we were debugging that and trying to understand exactly what was happening, one of the library developers experimented with directly connecting from Medusa to the S3 API. And that ended up working exactly the way that they wanted. So that turned into a custom Ruby gem that used the Amazon SDK to reach out directly to S3. So now Medusa supports Amazon S3 directly without any of the abstraction layers in between that make it look like a traditional file system. And what we found was for this application, that integration it offered all the performance that they wanted, offered better durability than the library had ever been able to build on site, and it was the most cost-effective option too. So all around, I feel pretty good about what we found.
Thanks, Chris. So now I get to talk about some of the S3 features that we use and that I really like. So Chris kind of alluded to cross-region replication. Cross-region replication is basically a feature that lets us create our geographically separated data backup. Our main S3 bucket is in the Ohio region, and our backup bucket is in the Oregon region. For our backup bucket in the Oregon region, we use S3 Glacier Deep Archive for the backup because that provides us with the most economical storage for our backup solution. One of the other features that we really is important to us because it helps us save money on our storage. And we have about 214 terabytes of storage. For some people, that's a lot. For other people, that's hardly any at all. But we have about 214 terabytes of storage. And we like S3 intelligent tiering because it automatically moves objects to the most economical storage if they're not being used. We use the instant access options with intelligent tiering, and the reason we use that is because there's no application changes that were needed. We still use the same S3 API, and our applications are able to retrieve the information they need instantaneously, or low latency is the correct word to use for that. So there are asynchronous intelligent tiering options that do exist, but they require a different retrieval method, and we do not use them. So I'm going to show you a table here that kind of gives you kind of the breakdown of the intelligent tiering classes we use. There's intelligent tiering frequent access, which new objects or objects that were just accessed will immediately go into. And then there's other intelligent tiering storage classes that after 30 days and after 90 days, your object will get put into, I should say 30 days or 90 days after they have not been accessed at all, your object will automatically go into, and that storage is a lot cheaper than the frequent access storage. So let me give you an example of how we save money with that. So given the way our storage is used and the way we access our storage, we have 214 terabytes in our main S3 bucket. But we have like a whopping 187 terabytes that are in the intelligent tiering archive instant access tier, which is the cheapest storage tier that there is in intelligent tiering. And because of that, our storage per month for those 214 terabytes comes to about $1,300 per month. If we were not using intelligent tiering and instead we're using standard S3 costs, that cost would be around $4,800 to $4,900 a month, or $3,600 a month saving on our storage bill. So given that, the next slide, we kind of want to go through kind of quickly how the library IT manages their AWS bill. It doesn't happen by accident. We have monthly meetings. There's 5 of us in library IT that meet every month and kind of go over any issues regarding AWS costs that need to be addressed. We also have regular meetings with our technical account managers, our TAMs, and they're able to help us to kind of dive real deep into the workings of our accounts and help us understand how things are working, especially pertaining to cost. And then our solutions architect, he helps us even understand the costs even further.
Yeah, so my role for the cost is to help all my customers understand what's out there, how they can use it, kind of the art of the possible, but also how much is it going to cost. And so we work with our customers to make sure that their applications are well architected, and one of the pillars of well architected is making sure that things are running economically and you're getting the best value for your investment. And I'm paired with an account manager who also has access to credit programs, discount programs, and can find even more opportunities. So if that's interesting to you, go ahead and reach out to your account team because we're here to help you.
So in addition to those steps, we also use AWS budgets, and what that does for me, I get a weekly email that basically tells me if my forecasted spend for the month is going to be higher or below my budget. And if we need to dive kind of deeper into any cost issues, we use Amazon QuickSight reports to give us that type of information. So we also use other savings programs besides intelligent tiering and Glacier Deep Archive. So what this slide is basically, it matches up the services that we use with the Amazon savings programs that lets us save money. And I should point out that almost all of these programs that we use don't require any application changes or changes to infrastructure. And Chris, I think you wanted to talk about
Yeah.
some of them as well.
Yeah, the one that can be a little bit disruptive is the AWS Instance Scheduler. And that's a solution you can deploy to your account that allows you to set a schedule where you want to turn certain instances off at a certain time and turn them back on at another time. And the reason that I like to highlight this is turning things off when you don't need them is one of the easiest ways to save money in AWS. And if you've got applications that are used for like a development workload and they need to be available during business hours, but that's all, a little bit of trivia, the 40 hours of a week that constitute the business week, if you divide that out of the total hours in the calendar week, it's less than 25%. So if you turn things off overnight and keep them off over the weekend, you can save 75% on like your developer workstations. So that's always something that I suggest to my customers. And with the University of Illinois, the on-premises virtualization didn't give people any reason to shut their machines off. The billing was the same whether it was powered on or off. So it's something that's really easy to overlook for a customer that's coming out of an environment like that into this new world. Yes, and so if we talked about things that sound cool, services that maybe you don't have a lot of familiarity with, definitely check out the AWS Skill Builder. And we've got courses to teach these skills, help you come up to speed on all these services, and build some really amazing things like the library did. And then you can continue down that road, get some certifications, and build some cool stuff. So I'm Chris Keene.
I'm Joe Troy.
And we're going to stick around and answer some questions. While we get the microphone set up, we'll bring this up. We would love your feedback. So please take the survey. Please give us the feedback. We're driven by what we hear, and we want to get your perspective on what works well at the summit, what we could do better, and we'll take that and try and make it better next year. So thank you all very much.
Thank you.
And we're ready for some questions if anyone's got it. Yeah.
Thank you. For that cost slide that you showed, was that for a single region savings or was that across multiple regions?
So most of our stuff is run in the Ohio region, but the savings programs could apply to any region. The Amazon S3 Glacier Deep Archive is actually in the Oregon region, but everything else is just in one region. I'm not sure if that answers your question or what you're trying to get at.
In that one slide, you talked about 215 terabytes, I believe.
Oh, right.
Yes.
Yeah, that's a good question. So that's 214 terabytes in the main S3 bucket that's in the Ohio region, and I'm not sure why that's
There you go.
that's doing that. So we also have another 214 terabytes that via cross-region replication is in the Oregon region. And of course, that is using Amazon S3 Glacier Deep Archive. So it is actually, I don't know the exact figure, but it would be cheaper than that $1,300 per month.
Yeah, Deep Archive is right around $1 per terabyte per month. Not exactly, but pretty close.
I'm going to advance the slide to the survey again. I apologize for that.
Thank you for the presentation. What is the software that manages knows where all your files is and handles replication between AZs and regions and checks checksums? Is all of that Medusa? And if so, how was the migration of that from on-prem, since there's a lot of cloud aspects to that?
Right. So as far as the cross-region replication, that's entirely an Amazon service that we just have to set up, just kind of configure, and then it runs. But your other question, as far as things like figuring out file types and checksums, that's going to be metadata for our digital objects. We have our web applications run on Ruby on Rails. So the code that does that is either going to be Ruby on Rails code, or it's going to be some other function, which could be Python or something else like that, that would actually do like the checksum, or ensure the file type is correct, that type of thing. So I don't know if that answers your question about all the components you're interested in.
Yeah, yeah, thank you. Just kind of curious on what you're using to manage sort of your files and sort of your mid-tier business logic, if how custom that part of your architecture is, and is that?
Right, so as far as managing the files, Chris mentioned that we have a custom Ruby gem that basically does direct calls to the S3 API to manage the files. I think you also asked how we actually migrated the data to the cloud originally, and that was really just done using the S3 API calls as well.
Yeah, most of that middleware is homegrown, where they store a lot of the metadata in an RDS database, and the library applications are responsible for checking and making and reporting it back. Let's see, I thought we had some questions up here.
Yes, sure. I have few questions. So you said 214 terabytes of data. That means it's only static data, or are you getting any real-time data also?
Excuse me?
You're getting static data. That means it's static, or you're getting real-time data also. 214 terabytes of data, you told. So that's it. You're not going to get any more data, or are you expecting any real-time data?
Right. So actually, these slides are 2 weeks old, and we're actually up to about 220 terabytes right now. So we're growing at a pretty rapid pace. We've even had researchers ask us, like, what would happen if they presented us with another 200 terabytes of astrophysics data. So we're growing at a pretty rapid pace. In 2017, we had 150 terabytes of data. So now, 5 years later, we're at 220 terabytes of data today.
Okay. And one more question. EC2 instance, you were saying like you can turn off the instance when we are not using it. So how can we do that?
So there is what's called the AWS Instance Scheduler, which you can provision using a provided CloudFormation script from Amazon. And then once you spin up, if you run the CloudFormation, and you can go and read the documentation, it's fairly straightforward, and then you basically spin up the infrastructure to handle the AWS Instance Scheduler, which is a Lambda function primarily. And then what you would have to do, you would have to go into a DynamoDB table that is provisioned for you as well, and enter in the schedules. And when you enter in the schedules, there's a place to put a tag, and then the tag that you put in that schedule has to be a tag on your EC2 instance. So you basically, I think our tag says something like Monday through Friday schedule, and then the DynamoDB DB table has that Monday through Friday schedule, so it knows how to do that for you. And we use it for our development machines and our demonstration machines, not for our production machines. But we have like 7 of them, so it's good for us to turn them off when we're not using them.
Yep. So everybody, we are out of time. Thank you for your questions. We're going to wrap it up. Joe and I will hang out. If we didn't get to answer your question, we can take it offline. But thank you, everybody. It's been a pleasure.
Thank you.